Hello everyone, welcome back to another Tooltip Tuesday. Today's episode is on the CPX BlankX software, and here I have a geometry already defined, and we have 5 different segments within the geometry. The raw blank diameter is 16, and we can see that the smallest diameter is 9 millimeter. Now we all know that the play button, what is shown here, will actually simulate the grinding process in a 2D environment. So let's go ahead and select that, and it brings us to this page automatically where you can actually see the blank and the geometry to be ground, and both the roughing and the finishing wheel are ready to be simulated. By dragging the progress button, we are clearly able to see the simulation, or you could run it automatically by pressing the play button, but you may want to increase the speed if required or stop it, plus also do jump to the next segment as shown here, or you can also go back if required. Additionally, on top here we have the zoom in and the zoom out selection, along with the home button, and also you have a window zoom as well available. For example, if you want to zoom into this section here where there's a radius, that is how you do it. So let's go back to the home position, and something which I would like to discuss a little bit more is the show or hide the grinding path. So by selecting that, what's going to happen is you will actually start seeing another set of lines appearing which is very close to the actual geometry to be ground. Now, to understand this actually helps us to debug if there is any programming mistake, or if there is any section that is not ground properly. So both the grinding wheels, I have purposely added a larger radius, and the green dot, which represents the extended line from the center of the radius, and the orange one represents the line, imaginary line between the center of the radius on the finishing wheel. Now this is good to actually track what exactly happens here. So having a closer look at this, you can see where the grinding wheel is coming into contact. Now the software assumes that your radius is uniform and it is concentric to the actual center of the radius itself. If there is an uneven wear, the software wouldn't know, and that will probably end up in giving a pip on your drill point, for example here. Now if you're having a finishing wheel going through and finishing it, then that doesn't really matter. So here we go. So this is the show and hide the grinding path, beneficial for debugging. Mostly this function is used when you have a programmed geometry, and the final geometry what you have is having, especially at the corners of intersection of two segments, that's where the most impact is seen. This is the easiest way to understand. Now again, one more thing to note here is the software assumes that the radius entered is concentric to the center, uniform, and if any error in the actual grinding wheel on the machine, the software wouldn't know. Plus the other thing to note here is the radius need to be as close to the physical radius on the grinding wheel. Otherwise there's not going to be a match between the result what you're seeing here. So I hope there is something you got out of today's episode. Thank you once again for watching, and we will see you next time with another Tooltip Tuesday.